Hi, statistics students. This video is for chapter 3.3. We'll talk about two rules that can be used to find probability of A or B and probability of A and B without, using like the two-way table. Look at the column and circle the numbers like that. This is a more general rule that you can use either not in a two-way table situation. So, but most of the time we do not need this multiplication rule the one that we did in 3.1, that's good enough. Okay. So, but I just want to let you know that in probability, we do have these two rules. So the first is called addition rule. So addition rule is used to find or in the procedures. So if you're looking for A or B, where A and B are two different outcomes, and you want a probability of either A happen or B happen, so formally the addition rule, it goes probability of A or B is probability of A plus probability of B minus probability of A and B. That means because when I add these two probability together, I double count A and B at least in one of them. So I subtract them because when I do probability of A, it would include a little part of also B happening, right? Because there's some part that B would happens together. And then when I do B, I include that again. So there is two A and B add together, so we subtract it. So if you don't want to, do the circling of the outcome of A or B, by definition in a two-way table, you can do this. But most people can live by just circling the numbers. Now, but if A and B, you can see that in this formula, if A and B is 0, that means if A and B are mutually exclusive, I don't need to subtract a 0. So probability of A or B is just probability of A plus probability of B if A and B are mutually exclusive. So this is a good addition rule to use if you know A and B cannot happen to each other. So you would just add each individual one together. Okay, so for example, I want to toss a fixed phase die once and use the addition rule to find probability of A or a 1 or odd. So 1 or odd actually are not mutually exclusive. They do happens together. So what I'll do is I just probability of 1, which is easy to find, is 1/6. Probability of odd is 3/6. But when 1 and odd happens together, there is only one chance that they happens together because 1 is one of the odd, right? So that would be 1/6. So you do 4/6 minus 1/6 is 0.5. So this is one way of doing it by the addition rule. You can also use the sample space by definition. You can think of how many ways can I have 1 or odd. So odd actually, so that would be 1, 3, 5. That would include 1 and all the odds. So you can say, oh, the number of ways is 3 ways. The total number of ways is 6, so it's 0.5. You can also do that. So it's the same. So that's why I say if you use the definition method, by definition of what is or means either one, either A or B or both. Okay. In example 2, you can also use the two-way tables to illustrate this addition rule. So in case you find the previous method in 3.1 really difficult, you can use the addition rule to find A or B. So for example, use the addition rule to find mail or iPhone. So mail will be your A, iPhone is your B. So you will say, okay, by the addition formula, that would be probability of A plus probability of iPhone minus probability of mail and iPhone. We know this is easy to find. Mail and iPhone is just one cell, would be this one, right? So you would say minus 18 over 51. What is mail, probability of mail? Mail is just the whole row of mail, so it'll be 18 plus 2 plus 1, that's 21. What is the probability of iPhone? That's also easy to find. It's this whole thing. So you add these two together minus the overlap cell. That would be 0.8823. So you notice that you have to do fraction, add and subtract. So the trick is don't simplify. Just keep the same grand total as a denominator and then add and subtract them. You will get the same answer. Versus if you do by definition, we do this before in 3.1. By definition, probably of male of iPhone would just be circling, right? All the iPhone, all the male. These are all the male. Add all the circle number together. So be 18 plus 2 plus 1 plus 24 over the grand total of 51. You'll see that this is 42, 42, 45. 45 over 51 is the same as this one, 0.8823. So you see how by definition of circling, it's the same as using the addition rule. But if you want to use addition rule, you can do that too. Okay. So you erase this. The only bad thing about using the sample space method is you keep on erasing them. The second formula that is useful for us is multiplication rule. Now in the classwork, I don't require you to do this. So you just do the definition is good enough. I don't want you to do it again and again. Multiplication rule is used to find probability of two events A and B. A and B. So probability of A and B is probability of A because A has happened. You want A happen first, and then probability of B after A has happened, right? This is by definition. A and B is two events, one after the other. There's not one event of two different quality now. So you can generalize it as probability of A and B as two different steps. A happened first, and then B happened after A happened. You can say it is one step also. So this two event could be in one step or multiple step. So in general, if A and B are independent, remember when A and B are independent, then A and B is equal to, so the whether you use B happen after A or just B, they're the same. So if they are independent, the probability of A and B is probability of A times probability of B. This is a special case only when A and B are independent. The first formula, this one is the general multiplication rule, the general one. But if A and B are independent, I can replace this just by B, because whether A happen or not does not affect B. So, and because of this formula, we can then calculate probability of A given B. A given B, if you look at the original formula of A and B, as is equal to probability of A times probability of B given A. So if you divide both sides by A, you will have probability of B given A equal to probability of A and B over probability of A. But if I switch them around, I say probability of A given that B has happened, then it's probability of A and B divided by probability of B. That's easy to remember. The easy way to remember is because this is a given, you have to remember that you are dividing the sample space of B, so that's why the bottom is probability of B. So basically, so just illustrate by this example. Now you do not have to use this formula. You can also do by definition. Also do the same by definition, like in 3.1. So this is just giving you an alternative way of finding conditional probability. So we'll do an example here. We want to find probability of a male given that subject use iPhone or choose iPhone. So by formula, this is A and this is B. So we divide it by probability of iPhone. The top is male and iPhone. Male and iPhone is what? Just one cell, right? Male and iPhone is 18 over 51. And iPhone is the whole iPhone column would be 42 over 51. So they're both divided by 51. You can cancel. It becomes 18 over 42 is 0.4286. Now, if I want to do by definition, remember how we do it? We would say probability of male given iPhone is changing the sample space to only use the iPhone row or column. So iPhone is here, so only because this is already happened. This is given. So my only attention is on iPhone. So the total column would be our sample space. And then we want male. Male is 18. So that is the answer. So you see that it is the same as 0.4286. So you can use formula or you can use by definition. By definition. So that is 3.3. So introduce these two rules. If you're comfortable with doing probability of A and B, probability of A given B, all those, by definition, you don't have to use the two rule, but you do have to kind of know that the addition rule is for or, right? The multiplication rule is for doing and then in 3.4, we would use the same multiplication rule for n to do event that involve multiple steps.